Okay, hello students. Today, for the lab 1 of ELEX 3430, we are going to set up a mini lab in a home. So because of this COVID-19 pandemic, so we need to set up a mini lab inside our home. Hopefully, after this video, you can build up a small lab in your home. These components, you should have a 12 volts DC power supply and this 9 volts battery. Okay, this small LED light and this small position sensor. Okay, and this a small fan. Okay, and this one inside this bag is a small proximity sensor. Okay, so to build up this lab, we also need a multimeter, a wire stripper, some wires, and I think inside the kit it should also include this 2 push button. Okay, with the light indicator, and these 2 push buttons. This one. Okay, and this 4 1 2 3 4 relays. Okay, also inside the key you should have this latched push button. Okay. First step, I advise you test this component first. So to make sure all the components is working. Okay. So first of all, let's start from this small LED light. Okay, we can use this battery. This 9 volts battery, and this should have a small cap with this battery. So hook up on the top of this 9 volts battery, and it will give you two leads. One is positive, one is negative. Okay. Now if I apply a voltage on this light, okay, it should turn on. Right? Okay, if it does not turn on, you could ask for a refund and change another one. Okay. This, the electric DC fan. Let's test it first. See, there's 2 wires come out from this little fan, and there's one is lead. One wire is red, another is black, and I hook up the wire with the battery, red to red. And black to black. It's running. Okay, that means this fan is good. Okay, now let's take a look at this proximity sensor. So how to test this sensor? Okay, this sensor technically is a normally open switch. Okay. Okay. We use a multimeter. Okay. Put the multimeter to this sound wave gear. So it will test the continuity of a circuit. So if you put the gear to this function, it will sound when the two leads measure the continuity. Okay. Okay. First, we measure this sensor. Okay, with the two leads, one and another. Okay. Now there's no sound. That means the circuit inside this sensor is open. Okay, this normally open sensor. That means in the normal condition, the contact inside the sensor is open. Okay. Now let's keep these two leads together. And use another small components and move these components close to the sensor. Okay, now it's sound. That means that the contact closed. So in the normal application, this part of the sensor can move with something, for example, a motor or something with movement. When something moves to this position, it will close the contact inside the sensor and give you a signal. So in your program, in your computer program, you can decide what to do for the next. Okay, this sensor is good. Put it in the bag. Okay, this one. We call it position sensor. So that means in the normal condition, you can see here on top, this terminal labeled common. Okay, so the middle one, the middle terminal, is labeled normally open. That means in the normal situation, the common between the common and this normally open terminal is open. Okay. In this terminal here, it's labeled normally closed. That means in the normal condition, these two terminals is closed. So let's measure it first. First, I measure these two terminals. No sound. Okay, it's open. This two terminal is closed. Okay. normal. Now if I push this small wheel, that means in the normal application, if something touch this small wheel and push it back, it will change the status of the contactors. Okay, so still normally open terminals. Oh, sorry. Okay. Okay, that's okay. So normally open, close, normally close, open. Okay. Yeah, this is correct. Okay, this component is good. Now, the push button. Okay, this is a push button that provides a momentary close of these two contactors. Right? So, normally these two terminals are open. If I push the button, it's closed. And if I release the button, okay, it is open. Okay, so the status here is only provide a momentary status of the close. Okay? So if you release the button, it's open again. Okay, this is good. Same thing here. Okay, yeah. Okay, another button switch, we call it latched. Okay, what does it mean latched? That means if you push the button, it can latch the status of itself. Okay, I measure this two terminals is open, but when I push the button, and it can hold the button inside this hole. Okay. In order to make it open, I have to push it again. Okay. Push, release, and it can hold the status. Push again, it can open. Okay, this we call a latched push button. Okay. We apply a voltage on this LED indicator. Just turn on. That means the indicator is good. Okay. And then we measure the status of this four terminal. So this push button provide two contactors. One is normally open, so one is normally closed. Now we put the multimeter to this sound sign and measure this these two terminals. So this is the normally open contactor, and push it. Okay, so that means the statute left, and this side is a normally closed terminal. Stop. Okay, yes, that's good. The same test here. Another one. Normally closed push button. Okay, right. Normally open. Okay, so all those components are good, and now let's look at this small relays. Okay, so you see on this relay, there's a schematic on the relay. Okay. On the left, it shows a coil. Okay, and on the left here, it shows 1, 2, 3, 4, 5, 6 terminals, and this is a double pole, double throw relay. That means this has 2 poles and also 2 throws. How do we test this relay? Okay, let's use that 9 volts battery over here. Apply a voltage on this coil. And when you apply the voltage on this coil, you can hear a slow click. That the contactor is closed and open. Okay, so this is normal. This is right. Okay, now we can use a multimeter to measure the continuity of these terminals. This is the pole. In the middle is the pole, and on the two sides, 2 terminals. So when you apply a voltage, this is the normally closed terminals. Okay, and if I apply a voltage on the 2 terminal, stop. Okay, so that means these contactors are good. Okay. Okay. Now, in order to wire up your circuit easily, I suggest you use a breadboard. You should have this breadboard in your term, from term 1, I think. So when you get into the BCIT, the first lab will ask you to purchase this breadboard. So we can use this breadboard as a wiring board, and we can install these 4 relays in parallel on the bottom. Okay. Now, in order to hook up these 3 control buttons to the breadboard, so I suggest you can use these small hard wires and fix it on the terminal of the push button, tighten it, and insert this wires on the breadboard. Okay, so it will be looks like this. Okay, the same apply here. I'll install 4 wires on these normally open and normally close contactor terminals. Okay, last one. And insert these 4 wires on the breadboard. So I know these 2 terminal, these 2 wires is normally close contactor, and these 2 terminal is normally open contactors. Okay, and the same thing applied here. Now, in the component keys, we have two power supplies. One is this 12 volts DC power supply. One is this 9 volts power supply. So for the 12 volts power supply, so we see initially we have this adapter connected on this power supply, but we need to hook up these 12 volts to our breadboard as the power source. Okay, now the procedure we're gonna do is just because I already cut this head off, so I will show you how to install this wire to the board. So we just basically use a plier, cut off the head, okay, cut off, and then strip the wire okay. And when I cut the head off, I don't know which one is positive, which one is negative. So I need you to make sure which one is positive and which one is negative. So I use a multimeter and put the gear to the DC measurement. Okay. And I plug the power supply to the wall outlet. So it's your 120 volts outlet on the wall. Okay, now I measure this voltage from the output of that DC power supply. Positive, negative. So now I got the negative 12 volts reading. So that means this lead is positive. Okay, 12 volts positive. So this lead is my positive. So I connect this positive wire to my positive terminal on the breadboard. And negative wire to the negative terminal of the breadboard. Okay, now I have this 9 volts power supply hooked up and this 12 volts power supply hooked up. I have 12 volts on the top row and 9 volts on the bottom row. Okay, and then I want to connect this DC fan load to the breadboard. Okay, also you see there's a adapter on the wire, so I need to cut this off. Okay, and strip the wire. This is the negative. That's good. Okay, and I insert this fan load on this side. Maybe you can use as solder, make the tip harder, and then you can easily insert on the breadboard. Okay, now I have all this Minilab set up. So this side we have the control push button, the lights, the load, and this side we have the power supply, and the bottom line we have the control relay. Okay. In the following labs we are going to wire up those components and test some control circuit.